This section on radical exponents is going to probably take you more time than most of them. They possibly could have extraneous solutions, so all of the solutions should be checked. I've got quite a few problems here, so I'm not going to check every solution, but I am going to go through some of them for you so you can make sure that you know the algebra involved. But be prepared to spend quite a bit of time on this particular homework section because it is involved, and it is going to be time consuming. So I'm trying to give you a lot of examples to help you out with that. So what do we mean by a rational exponent? Well, it's an exponent that's a fraction. So as you can see, this one, the variable has an exponent of 3/2. So that's a rational exponent. Now, how do you solve them? Well, you're going to be able to multiply that exponent by its reciprocal and it'll turn into a 1. You have to keep in mind that if the top part, the numerator of the exponent, is even, you might have a plus or minus answer, so you'll have 2 to consider. If the numerator is odd, however, you will only have one answer. You won't have to worry with plus or minus the result. So let's go through a few of them. I've given the explanation here for you to have in printed form when you need it. But let's do a couple of examples and see if that doesn't help us more. First, I see that I have my rational exponent and variable with a rational exponent on one side. It's isolated, and that's how I want to start. So I'm going to get rid of that rational exponent by raising x to the power of 3/2, and I'm going to take that and raise it to the power of 2/3. Now remember, when we raise an exponent to a power, we multiply. Multiplying 3/2 times 2/3 is, in essence, they would cross reduce and it would turn into just the number 1. So when I do that, I'm going to just have x, and that's my goal. Now, because I did this, though, to the left, I have to do the same thing to the right. So I've got to take 125 and raise it to the power of 2/3. Now, that's not quite as hard as it seems if you remember the rules about rational exponents. What we say is that this denominator is the root, so is this going to be the third root of 125, or the cube root of 125 squared. So the top part is our exponent, the bottom part is our root. I'm going to write it like that. I'm going to say it is the third root, the cube root of 125. And then I could square the 125 under the radical, but it's easier, since I do know that 125 has a cube root, it's easier to square it once it's finished. Either way is acceptable. So what is the cube root of 125? Now you can look this up with your calculator, of course. And if you're not sure how that works with your calculator, let me suggest that you try this. You say 125 raised to the power of, remember, the cube root is like raising it to the power of 1 divided by 3, isn't it? Or 1/3? I don't know if you can see that. Let me see if I can raise that up so you can see it a little better. Not happening, is it? Okay. Calculator might have to take a break on us here. See if I can get the light fixed. Hang on just a second and I'll get it fixed for us. Now you should be able to see it, because 125 raised to the power of 1/3. You'll have to figure out how your calculator raises something to a fraction, but you should be able to do that. And if I hit enter there, I'll see that it is 5. So the cube root of 125 is 5. I can resolve this by saying x is equal to 5 squared. Therefore, x is going to equal 25. And when I check it, I'm checking that x is equal to 25. So I'm going to underline it so I know what I'm doing. And I come over here and I say, okay, so 25 raised to the power of 3/2 is supposed to be equal to 125. Well, let's fix this back as a radical, okay? Take it from rational exponent to a radical. And let's say, what is this? Well, it's the square root this time of 25. And once again, the exponent it's raising it to is 3. So what is the square root of 25? Well, that's 5. 5 raised to the power of 3. We should know that one because we just found the cube root of 125, didn't we? And so that does check for us. Now, if this numerator up here had been even, we would have had plus or minus over here as our answer, plus or minus the cube root of 125 squared. But we didn't because we had a numerator that was odd. Let's do a different one that has the numerator that is even and see how it changes for us. So I've got 3x to the 4/5. Now note that x is the only thing being raised to the 4/5. The 3 is just stuck out front. So it's not included in that rational exponent, okay? So I'm going to say I need 3x to the 4/5 to be isolated. I'm going to have to add 5 to both sides, okay? I've got to get this rational exponent term all by itself. And when I add 5 to both sides, I say 43 plus 5 is 48. And then I need to get this isolated. I got it isolated. I need it to be a coefficient of 1. So I'll divide it by 3 and divide both sides by 3. I have x to the power 4/5. And that's going to be 48 divided by 3, which is 16. Okay, now I'm to the point where I can say raise this exponent, see if I can put it in brackets here, to the power of 5/4. But I also have to raise this term to the power of 5/4. I should have left room here to write. And this time I have to say plus or minus. Why? Because this numerator over here was even and not odd. So when I raise these two to each other, I remember you multiply them together, they cross reduce, it becomes a 1. And this is equal to plus or minus. And what we've got here is the 4th root of 16 raised to the power of 5, okay? Okay, so what is the 4th root of 16? Now you could do this with your calculator, but if you just think a minute, you know that 16 is 4 times 4. And 4 is 2 times 2. So I got 2 times 2 times 2 times 2. Well, that's 4 2s, isn't it? So really this I can cross out and say that's really 2 raised to the power of 5, isn't it? I'm trying to keep from having to write the problem over and over again. Well, what is 2 raised to the power of 5? My solution here is going to be plus or minus 2 raised to the power of 5. And this one you're probably going to learn pretty quickly. Don't forget plus or minus. The solution is plus or minus 32. Now, I can check that for you real quick, but I'm going to have to do what you're probably going to have to do and add paper because I don't have enough room to check everything, okay? So let's go to a blank sheet of paper real quick. And let's say I want to check x is equal to 32. I'll check that one first. The problem would be 3 times 32 raised to the power of 4/5 minus 5 is equal to 43. Okay, so when I do 32 raised to the power of 4/5, I'm going to say that is really the 5th root of 32, and it is raised to the power of 4, right? Okay, so I've got the 5th root of 32 raised to the power of 4 minus 5 is equal to 43. And the 5th root of 32, we talked about this before. I think we've talked about it before. You can do it by saying 32 to the power of 1/5 if you wanted to. But you're quickly going to remember this one. It is a 2. 2 times 2, 2 multiplied 5 times is going to give you 32. So what I've really got here is 3 times 2 to the power of 4 minus 5, and that's equal to 43, right? Okay, what's 2 to the power of 4? Well, 4 2s is 16. So I got 3 times 16 minus 5 is equal to 43. And what I have here is 48 minus 5 is equal to 43, and that checks out. So this is a good solution for me. Now let's check another one. Like I said, I probably won't take as much time checking every one of these because I want to give you a lot more work solving them than doing the checking. And this is the algebra that you probably already know anyway. But let's see what we do with this one. We say 3, and we say the x is replaced by negative 32. It's raised to the power of 4/5. We subtract 5, and we say that's equal to 43. Now, a negative 32 that would be raised to the power of an even number would of course be positive, but let's do this kind of a different way. Let's say this is 3, and go back and say the same thing we did. It's the fifth root of negative 32. Well, does a negative have a fifth root? Yeah, a negative does have an odd root. It's simply the negative, okay, the negative of the root. And this is raised to the power of 4 minus 5 is equal to 43. If you need help with this algebra, ASC is a good place to get started with getting that help you need, okay? Now, what is the fifth root of negative 32? Well, that, this time, is negative 2. Remember, I'm just crossing this part out and replacing with a negative 2. In other words, 3 times negative 2 raised to the power of 4 minus 5 is equal to 43. Now, when I raise a negative to an even power, it becomes positive, doesn't it? Negative 2 4 times multiplied together is going to give me the same thing that positive 2 multiplied 4 times together is going to give me 16. So I have 3 times 16 minus 5 equals 43. And that gives me 48 minus 5 equals 43. And that's okay. So this one checked as well. Now let's see what we have down here with number 3. It's 8 times x to the power of 9/7. And that 8 to the x to the 9/7 minus 24 is equal to 0. I really want to get rid of that rational exponent, so I'm going to isolate that term. I'm going to add 24 to both sides. So I end up with 8 times x to the 9/7 is equal to a positive 24. Okay? Now, when I look at the 9/7, it's an odd number, so I know I'm not going to have a plus or minus answer. I'm just going to have one answer here. And let's see, hang on a second. And to get rid of that exponent, I'm going to need to raise it to the power of 7/9. But first, I need to get rid of this 8. I'll divide both sides by 8. I end up with x to the 9/7. Try to leave room to write this time. Is equal to 24 divided by 8 gave me 3. And now I can raise this to the power of 7/9. I'll have to also raise this side to the power of 7/9. You can use any brackets you like. Parentheses or these hard brackets, whatever you like with it is fine. And this becomes x, and it's equal to 3 to the 7/9. Now, 3 to the 7/9, I, can just leave that as my answer if I want to, because I'm not going to really find it as a solution. I'm not going to find a number for it when I try to rationalize it or simplify it. It's also pretty easy to check it this way if we leave it in this format. So let's try the check, and I'll see if I can show you what I mean here. When I check, I'm going to say 8 times, and instead of x to the 9/7, I'm going to put in there 3 to the 7/9, and then I'm going to put my exponent of 9/7, okay? Minus 24 is equal to 0. I just replaced the x with 3 to the 7/9 is all I did. Once again, you'll see I've got inverses, don't I? So I can just say this is going to be 8 times 3 to the power of 1. So it's 8 times 3 minus 24 is equal to 0. And that would be, of course, 24 minus 24 equals 0. So my answer is good. And I can see that 3 to the 7/9 works as checking it is even easier, maybe. All right, let's work on this next one here. This time I have a binomial. It's already isolated. The rational exponent term is isolated if you consider this binomial as a single term. So all I have to do is, I'll write it again out here. I'm going to say x minus 3 raised to the power of 2/3. I'm going to have a plus or minus, right? And then I'm going to take this whole thing and raise it to the power of 3/2. And that's going to equal 25, also raised to the power of 3/2. But because the original exponent had an even numerator, I have to say plus or minus here, okay? All right, so let's see what this does for us. I end up with just x minus 3 to the power of 1, right? So that's going to equal, and I'll go ahead and put my plus or minus here. And what is 25 raised to the power of 3/2? Well, if I think about that, it's the square root of 25, which is 5, right? cubed. Well, the square root of 25 is just 5. If I replace that with a 5, I have 5 cubed. X minus 3 is equal to plus or minus 5 cubed. What's 5 cubed? I think we know that one, don't we? It's 125. X minus 3 is equal to plus or minus 125. Now, let's take this 3 to the other side here, okay? Because we don't really want it over here. We're going to add 3 or negative 3, add 3 to both sides, and I'll say x is equal to 3 plus or minus 125. It's always good to add it in front of the plus or minus because we're going to do this next. We're going to say, what are my solutions? There are 2 of them. I've got x is equal to 3 plus 125, and that would, of course, be 128. And then I've got x is equal to 3 minus 125, and that would be a negative 122. So here are my 2 solutions, the 2 that I would plug back in and check, and I'll see if they worked. Go ahead and do that. I'll tell you that both of those solutions are good ones, but you should be able to do the math to check them out yourself, okay? Now for these problems, I'm actually giving you some extra examples here on page 19, and I'm hoping I've given you enough room to write them. If not, you might want to have some extra paper available just in case. The first one is sort of the same thing we've been looking at. It is a term, which is a binomial raised to a rational exponent, multiplied by a coefficient, and it's equal to another term. But let's take care of this coefficient first. We'll divide both sides of this equation by excuse me, the coefficient of 2. When I do that, 2 divided by 2 is, of course, 1. And 54 divided by 2 is 27. Now, I'm trying to save space. That's why I'm writing it all in one step like this. So now I have my term, my binomial with a rational exponent equal to 27. And I'm going to get rid of the rational exponent, which has a 3 as the numerator, so I don't have a plus or minus solution. But I'm going to raise it to the power of 2/3, which means I also have to raise 27 to the power of 2/3. I get rid of my rational exponent on the left, so I have x minus 3. And then I have the cube root of 27 squared. Now, you might at one point just stop writing this step down and just say that to yourself. I have the cube root of 27. If you know what that is, I do. It's 3, and I'm going to square it. So really what I have over here is the number 9. I'll write that out. This is x minus 3 is equal to 9. So x is going to be equal to 9 plus 3, which is going to be 12. And that's a solution that I can come over here and check. I'm going to check the solution x is equal to 12 right here. So I'm going to just plug it in. I have 2 times 12 minus 3 raised to the power of 3/2. And then that's going to equal 54. All right, 12 minus 3 is 9. So what I have is 2 times 9 raised to the power of 3/2 equal 54. And once again, I have this time the square root of 9 cubed. Well, the square root of 9 is, and you can write that out if you need to, but the square root of 9 here is 3. 3 cubed is 27. And that's equal to 54. So 2 times 27 is equal to 54, so that solution checks. Now, once again, write as many of these steps as you need to make sure you don't make any mistakes, even if you think you're duplicating effort. And then as you get to where you can do this rational exponent transformation or transition to a radical in your head, then go ahead and do it. But just make sure that you are, if you're not comfortable, write it down, okay? Okay, for number 6, we've got 27 minus, and there's our binomial with the rational exponent, isn't it? Equal to 0. And I'm going to get rid of everything over here except for that term. And so I have to subtract 27. Now, this one is a little more awkward for me. And that's going to equal negative 27. And when I divide both these sides by a negative, I'm just going to say, well, they both turn into positives, don't they? So now I have x minus 3 raised to the 3/4. Well, I think I left room to just raise that to the 4/3, didn't I? And at the same time, I'm going to raise a positive 27 to the 4/3. Since the original exponent had a numerator that was an odd number. I don't have two solutions here. I just have x minus 3. 3/4 times 4/3 gave me 1, right? And this time I have the cube root of 27, and I have it raised to the 4th power. I'll write that down for you. It's not one we've kind of done a lot with. Cube root of 27 raised to the power of 4. But the cube root of 27 is simply 3. So that's going to be 3 raised to the power of 4. And 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 is 81. Now, that's quicker for me than a calculator. So I've got 8x minus 3 is equal to 81. And when I add 3 to both sides, x will equal 84, won't it? So let's check that solution. And I come over here and I say 27 minus, in parentheses, 84 minus 3 raised to the power of 3/4 is equal to 0. 27 minus, well, inside parentheses here, this is going to be 81 raised to the 3/4 is equal to 0. Well, this time I'm looking for the 4th root of 81 cubed, right? Do you need to write that down? The 4th root of 81, and after I find it, I will cube that. Now, the 4th root of 81, like we did once before, we said, well, 81 is 9 times 9, but 9s are 3 times 3, so 4 3's multiplied together, this is going to be 3, isn't it? So, I'm sorry, that's supposed to be a minus sign. So what I'm saying is 27 minus 3 cubed, 3 cubed is 27, is equal to 0, and that checks. So we have a good solution. Number 7 has already really set up for us. The rational exponent term is all isolated on this side. It is, however, an even number. So let's say we're going to have a plus or minus, but let's say we're going to have to raise it to the power of 3/2. And then I'm going to move this over a little bit, write it out here. I'm going to have to say plus or minus 36 raised to the power of 3/2, okay? All I did was scoot it over a little to give us some room to write that plus and minus sign. So I have x minus 5 on the left, and over here I've got plus or minus, plus and minus, the square root of 36, and it's going to be cubed, right? So the square root of 36, everybody knows that one is 6, isn't it? So 6 cubed is what I'm looking at. X minus 5 is equal to plus or minus. Now 6 cubed, if you don't know what 6 cubed is, then you might want to go to your calculator and just kind of type it in, okay? So you can say 6 and use your little arrow button to give that exponent of 3, and you come up with 216. And that's one you're probably going to want to kind of memorize anyway. So it's 216. Now I'm going to add 5 to both sides, and I'll have x is equal to, let's put it in front of that plus or minus because it's going to help us when we're getting our two solutions. The first one is x is equal to 5 plus 216. Well, that would be 221. And the second one is x is equal to 5 minus 216. Well, that's going to give us a negative number, right? Negative 211. We're going to have to check both of them. I'm going to move up a little bit to give myself some extra room here. So I'm going to check this x is equal to 216 solution first. And I'll plug it in. I say, did I say x is equal to 216? Sorry, it's supposed to be x is equal to 221, right? So I'm going to plug it in here. I'm going to say 221 minus 5 raised to the power of 2/3 is equal to 36. And this is going to be 216 raised to the power of 2/3 is equal to 36. Now, this is the cube root of 216 squared. So it's a cube root, and then I take it and square it, and that's equal to 36. Now, if I don't know, I do because I just did the reverse of this. If I don't know the cube root of 216, I would type in 216 to the power of 1/3 and get it, and you would find out that this is really 6, and 6 squared is 36, so I can say, yeah, that really works. Let's check another one. Let's check the solution that was x is equal to a negative 211. So I've got negative 211 minus 5 raised to the power of 2/3 equals 36. Well, this gives me a negative 216 raised to the power of 2/3 is equal to 36. And this is the cube root of negative 216 squared is equal to 36. Now, we do have odd cube roots of negative numbers. They're simply the negative root, right? So negative 6 times negative 6 times negative 6 would give me a negative 216. So this is negative 6 squared. Well, negative 6 times negative 6 is a positive 36, so that checks. Okay, last problem like this. Down here I have a trinomial raised to a rational exponent. It's got a couple of other things muddying up the side that I want to take care of. Because I'm running out of space here, I'm going to see if I can do this a sort of shortcut way. First, I'm going to get rid of anything that's added or subtracted. So I'll subtract 1 from both sides to get rid of this 1. I'll just mark it out. And when I subtract, I say 5 minus 1, I end up over here. Let me just mark that out and say I end up with 4. And now you can see I have 4 times my term is all that's left on this side equal to 4. Well, let's divide it by 4. This becomes a 1, and I have a 1 on this side. Now all I have to do is raise this to the power of 2/3. I don't have to worry about 2 solutions because the numerator was odd. So I will raise this one to the power of 2/3. And it's just 1 to the 2/3. Keep in mind that 1 to any exponent is always going to equal 1. So you don't have to worry too much about it. We ended up with this one getting rid of everything except for x squared minus 3x plus 3. And that's going to equal, over here, a 1. And then I just need to you know how to solve this one. This is something we've done forever. We're going to subtract 1 from both sides so that we have a trinomial. 3 minus 1 is a positive 2. And then we're going to try to factor this trinomial to see if we can come up solutions, and we can use the zero product factor to set them equal to 0 and come up with possibly 2 solutions. So I know this plus says look at the first sign. They're both going to be negative. So I've got x minus. And the only factors of 2 are going to be 2 and 1. But let's check it and see. X times x is x squared. Negative 2 times negative 1 is positive 2. Negative 2x minus 1x is a negative 3x. So we have 2 good factors. We'll set each of them equal to 0, and then we'll solve. I know I'm going fast, but you should be too. This is something you've done now for a couple of semesters at least, right? Okay, let's check. See if I move up here. You don't mind if I move up and use this space. X is equal to 2 is going to be the first one I'm going to check. And I'll say 4 times 2 squared minus 3 times 2 plus 3 raised to the power of 3/2 plus 1 is equal to 5, right? Okay, so this solution, let's see what I've got. Let's do everything in parentheses first, right? What do I have? I have 4 minus, and we have to do the multiplication, 6 plus 3. Raised to the power of 3/2 here. And that's going to be plus 1 equals 5. So what's 4 minus 6? That's a negative 2, isn't it? I've got 4 multiplied times what? That's a negative 2 plus 3 is going to give me just a positive 1. To the 3/2 plus 1 is equal to 5. Okay, anything in 1 raised to any power, this is just the number 1. So 4 times 1 is 4. Plus 1 equals 5, and we're good with the solution x equals 2. Let's check the other one. We'll check x is equal to a 1. We plug it in. 4 times 1 squared minus 3 times 1 plus 3 raised to the power of 3/2 plus 1 equals 5. I know there's a lot of algebra in this. I told you this section was going to be tedious and long, but believe me, you need the practice to move on to what you've got to do next after this test, okay? 1 squared is 1. Negative 3 times 1 is negative 3. I've got plus 3 here, raised to the 3/2. Everything plus 1 equals 5. Well, a negative 3, a positive 3, those are going to cancel. All I have here is 4 times 1 to the 3/2, right? plus 1 equals 5. And once again, the 1 raised to any power is just a 1. So this is 4 times 1 plus 1, and that is going to equal 5. And that solution also checked. Now, this example, we're going to solve these equations in quadratic form, but we're going to be doing something unusual because they've really got, most of the time, negative exponents. And we're going to be using a procedure where we actually substitute in the letter u for the middle term most of the time, and then we use that to put in as far as the for the variables for the quadratic so that we can solve with the u. Then we're going to plug back in whatever we substituted the u for. Okay, I know that sounds really tedious, but basically you have to remember that you first got to get it in the form of a quadratic. So let's do that to this one first. And it's got the 3 terms that we need, but they're not all on one side. So let's move them over here where we have a positive coefficient of this squared term. I know it has a negative exponent, but let's just bear with it for now, okay? So we're going to say 3x to the negative 2, and I'll subtract this negative x to the negative 1, and minus 10 is going to equal 0. Now, all I did was get everything over to the left-hand side. I just need all to be on one side, so it's in the format of a quadratic. Now, the next thing I want to do is I want to find what I can make u, and then I want that to be able to it's usually the b term that I'm going to turn into u. I'm going to substitute. So let's try this. I'm going to say u is equal to x to the power of negative 1. That's what I'm going to try. Well, now, when I say that, then this x to the negative 2 becomes u squared, right? Because x to the negative 1 squared is x to the negative 2. Because remember, you multiply exponents when you raise an exponent to another power. So I'm going to say I've now got 3u here minus u minus 10, and that's going to equal 0. And that is so much nicer to work with. Let's solve that one, okay? What would we do to solve this one? Let's try to factor it. Now, it's not one of our easy quadratics, but let's see if it doesn't factor. The negative tells me I need one of each sign when I'm working here. I'm working with u's instead of x's, and maybe I don't recognize what factors of negative 10 and 3 together would, but I can do it really easy right here. I'll use my diamond method. I'll say 3 times negative 10 gives me negative 30. And the middle b term coefficient is a negative 1. I'm going to use that 3u here as my numerator in case I have to reduce anything. I know I've got 1 factor is plus, 1 is minus. So what am I doing? I'm looking for factors of negative 30 that are just 1 apart from each other. And when I see it like this, I automatically go, oh, well, 5 and 6, right? 5 and 6, I need to be a negative 1, so the larger number has to be negative. So the positive factor that I have is 3u plus 5. No changes there because these two numbers don't reduce. When they're written as a fraction, they couldn't reduce. But 3 and 6 would, so I would divide both of those by 3, and I would have 1u, or u minus 2. Okay, it factored. Let's check it. 3u times u is 3u squared. Meant to write that down as 3u squared. U squared, sorry. 3u times u is 3u squared. I've got 5 times negative 2 gives me negative 10. I've got 5u here. And I've got a negative 6u. That would give me a negative 1u. And that's what I needed in the center, right? All right, let's set these up. 3u plus 5 equals 0. And u minus 2 equals 0, okay? So I'm going to have 3u is equal to a negative 5, and u is equal to a negative 5/3. Let's do this one. U is going to equal 2, right? Now, those are our solutions as far as u goes. But now what I need to do is substitute x to the power of negative 1 back in for my u's, don't I? I need that to be I need to substitute back in so I can see what it actually is. So let me try that again and see if I can explain it better. What I have is, I know what u is, but now I'm really not sure what x is, because x is not necessarily 5/3. it's, going to have to be translated for us a little bit, if that helps you. So I'm going to replace it in here. I'm going to say if u is equal to negative 5/3, what I've got is x to the negative 1 is equal to a negative 5/3, right? I just plugged in u for my in my value up here where I had replaced it. Okay, I need to solve for x, not x to the negative 1. So how do I do that? Well, let's raise it to the exponent, okay? Let's raise it to a negative 1. Negative 1 times negative 1 gives us positive 1, doesn't it? So we have to raise this side to the power of negative 1 also. So I have now x. And when I raise a fraction to a negative 1, I really just flip the fraction. I keep the negative. It doesn't change that negative sign, but it turns the fraction over. So what I have is x is equal to a negative 3/5. Let's try this solution with u is equal to 2 this time. So what I've got is x to the power of negative 1 is equal to, that's what I said is equal to u, so u is now 2. Now I want to do the same thing. I'm going to raise that to a negative 1. I'm going to raise this to a negative 1. And I can end up with x is equal to a 2 raised to a negative 1 turns it into a fraction. It takes that whole number 2 to the other side of the fraction. It's really 2 over 1, isn't it? And it becomes 1/2. Now, it's not negative. It's just that the 2 goes down to the denominator. When it passes down, it stays positive, but it becomes a fraction. So I have two solutions. X is equal to a negative 3/5 and x is equal to 1/2. Now, I'm going to allow you the time to plug those back in, check for extraneous solutions, and just plug it back into the numerator, and you should see them both work. Okay, let's look at number 2. This time, I've got x to the 2/5 minus x to the 1/5 minus 2. It's already in a quadratic form. I just have to decide what's u. And I can usually use the b term. I'm going to make u equal to x to the 1/5. I think that'll work because if I squared it, I would have x to the 2/5. So if this is u squared, and that's what I want. Okay, in a quadratic format, let's see if I can factor it. I say both of these, one of these is plus, one is minus. I've got u's here. And factors of 2, well, it's got to be, I'm going to have a negative 2 and a positive 1 here. Let's check it. U times u is u squared. That's negative 2. And inside would be 1u. Outside negative 2u. That gives me a negative 1u. Okay, so I'm going to say u plus 1 is equal to 0. And u minus 2 is equal to 0. And u, is equal to a negative 1. And u is also equal to a positive 2. So let's plug it back in. I substituted in up here, didn't I? So I'm going to say x to the 1/5. I'm turning it around just because I like to have my x over here that I'm solving for. X to the 1/5 is equal to negative 1. And for this one, x to the 1/5 is equal to a positive 2, right? Okay, so those are my two solutions. Let's solve for x. How do I get rid of an exponent of 1/5? Well, multiply it times 5 over 1, right? And then I have to also raise this to the power of 5, don't I? When I do that, I have x to the power of 1 is equal to negative 1 raised to the power of 5. Well, that's negative 1 multiplied 5 times, isn't it? Odd number of times, it's going to be a negative number. Let's try this one. We're going to raise it also to the power of 5, or 5 over 1 if you want to, and we'll say that's equal to 2 raised to the power of 5. Well, this time x is going to be equal to 2 to the power of 5, which I happen to know, which is 32. And you would plug both of those in, check your solutions, and you should find out that they work. Now, here's the check for those two problems we did on page 20, because I want you to be able to go back and check your algebra. But this is something that you should be able to do by now. But if you have any questions, just freeze this screen and you can check your work with it. Okay, let's do some more of these. We're going to look at this middle term. We've got a quadratic here. And let's see if we can't plug in u for something and see if we can solve, because it is kind of hard for us to solve something that looks like this, and maybe we can use u to help us with it. So I'm going to take my variable x squared, and I'm going to say u in this particular case is going to equal, I'm going to let it equal x squared. If I do that, then what I've got is u squared minus 10 times u plus 9 is equal to 0. So now I've got it in a quadratic form, right? And I can solve for those. I've got this as the first term is squared. So it looks like it's doesn't have a GCF. Let me just see if I can factor it. I would say both of these signs have to be minus. I'm going to put u as the first variable here in the first term. And then I'm going to look for factors of 9 that add together to give me a negative 10. And of course, the only factors that would do that would be a 9 and a 1. So I check it. U times u is u squared, and that would be negative 9 times negative 1 is positive 9. That's a negative 9u minus 1u gives me a negative 10u. So I end up with u minus 9 is equal to 0, and u minus 1 is equal to 0. And this time u is equal to a positive 9. And u is going to equal to a positive 1. So let's plug it back in here and say if u is x squared, then what I'm saying is x squared is equal to 9 here. And over here I'm going to say x squared is equal to 1. Well, do we know how to solve this? Yeah, we have to say square root of this side and plus or minus the square root of the other side, right? So I'm going to say the square root of x squared is x. And that's going to equal plus or minus the square root of 9, isn't it? And I know that's going to be a 3. So I have two solutions out of this one. Right there I had 2. So I got x could be plus or minus 3. Now, for this one, I'm doing the same thing. Square root of x squared is going to give me x. Square root of 1 is going to give me, I have to do the plus or minus 1. So I actually ended up with these 4 solutions, which you would plug in and look for extraneous solutions. So try that, but they all do appear to check. Let's look at this one. I've got 2x to the 4th minus 11x squared plus 12, and this time I have to decide what's u, and I'm going to choose x squared again, because if I square x squared, I get x to the 4th, and that's what kind of cues me in. So I say u is equal to x squared again. I'll say this becomes 2u squared minus 11u plus 12, and that's equal to 0. And let's try factoring this one. So this plus tells us use the first operation for both sides. I know I'm going to have a u here, but I don't know anything else. I'm going to go over here and say, okay, this is going to help me. Diamond will help me. 2 times 12 is going to give me 24. The middle term, the b term, is negative 11. I know I would have a 2u to reduce if I need to, and I've got both of these are negative signs. So that gets me really started with this, doesn't it? So now I'm just looking for factors of 24 that when combined, when added together, really, they'll both be negative, will give me a negative 11. And the first thing I'm going to think about, okay, is 8 and 3. 8 plus 3 is 11. They're both the same sign. This one has to reduce, doesn't it? But divide them both by 2, I end up with u minus 4. That can be one of those factors. And this one is 2u minus 3. Okay, u times 2u is 2u squared. Negative 4 times negative 3, positive 12. There's a negative 8u, a negative 3u, combines to give me a negative 11u. So I say u minus 4 here equals 0, and I say 2u minus 3 equals 0. For the first one, u is going to equal 4. For the second one, they're going to make us work a little harder at that one, and u is going to equal 3/2. Okay, so let's plug it back in. If u is x squared, then what we're saying here is x squared is equal to 4, isn't it? And then let me go ahead and finish this one while I'm over here. Square root of x squared. And this is equal to plus or minus the square root of 4, which is going to be 2. I can sort of do that in my head a little bit as I get better at it. This one might not be so easy to do in my head. I'm going to say x squared is equal to 3/2. So when I square this first side, when I take the square root, I'm going to say this is going to be x, right? And this is going to equal plus or minus the square root of 3/2, isn't it? Well, that's fine, but I can't leave that radical in the denominator, so I'm going to have to get rid of it. And the way I would get rid of it is think about it like this. This is really equal to plus or minus the square root of 3 over the square root of 2, isn't it? And I'm going to multiply that times the square root of 2 over itself, which would give me the square root of 6 over 2, right? So what is my solution? It's going to be u is equal, I should have put plus or minus with all of these, plus or minus the square root of 6 over 2. That's going to be one of my, or two of my other solutions, okay? Okay, let's do another one. I've got x to the power of 4 minus 122x squared plus 121. Everything's over here except for zeros on the other side, so I'm in the right format. I just have to decide what u is, don't I? So once again, the b term, the b variables is x squared, so I'm going to say u is equal to x squared on this one also. That makes the first term u squared minus 122 times u plus 121, and that's equal to 0. Okay, just substituting in u for x squared, and then I can have it in a true quadratic format, okay? So let's look at these numbers. I don't have a GCF, so I can't factor anything out there. I'm going to have to factor this, but it's not going to be too bad. I'm going to say plus tells me use the first operation for both of them. I know this term is going to be a u. And really factors of 121 that will add to give me 122. Well, how about 121 and 1? That usually works pretty well. Check it out. U times u is u squared. 121 times 1, well, they're both negative. They give me a positive 121. 121u, negative 121u, minus 1u would give me my negative 122u. So I'm happy with that. And I have u minus 121 equals 0. And u minus 1 equals 0. So u would equal a positive 121. And u would equal a positive 1. And now let's plug in our x squared for u. X squared would equal 121. X squared would equal 1. The square root of x, and plus or minus the square root of 121, which I know that one, that's 11. So x is equal to plus or minus 11. Now, ones are easy, right? The square root of x squared plus or minus the square root of 1, which is just 1, isn't it? Now for the next problem, we've got negative exponents again. So this time I have x to the negative 2 plus 6x to the negative 1 equal. Let's first fix it so that everything's on one side of that equal, okay? So I'm going to say this is x to the power of negative 2 plus 6x to the negative 1. Whoops. And then I'm going to have to add 5 to both sides. So this will be plus 5 equals 0. At least I fixed that problem, right? So that is a 1. So now I need to decide what is u going to be. Well, here is my x to the negative 1, which if I square it, I'd get x to the negative 2. So I know u is going to equal x to the negative 1. That helps me. Let's plug in u. This would be u squared plus 6u plus 5, and that's going to equal 0. Okay, so let's factor this one. We have to use u plus for both of these. And we want factors of 5 that add to give us 6. And how about 5 and 1? Check it real quick. U times u is u squared. 5 times 1 gives me 5. This is 5u plus 1u, 6u. So I'm good. U plus 5 is going to equal 0. and u plus 1 will equal 0. So u is a negative 5, and u is a negative 1. Let's plug in for u, x to the power of negative 1 is equal to negative 5. And here the same thing, x to the negative 1 is equal to negative 1, right? Now, if I want to get rid of this x to the negative 1, I'll multiply it. I will raise it to another exponent. How about negative 1? Have to do the same thing here. This becomes x because negative 1 times negative 1 is 1. And this is a negative 5 to the negative 1. Well, I'm going to keep the negative out front because that doesn't change just because of the exponent. But I'll change it to a fraction and make it 1 over 5. So it's negative 1/5. Let's do the same thing here. We're going to raise this one to another negative 1 power. Same thing there. This is x. And this is the negative out front is not going to be affected by our negative exponent. But 1 over 1 is just 1, isn't it? So it becomes a negative 1. So number 7 is next. I'm giving you a good bit of room. We have a lot of these that we're working just to give you practice with them or to show you some good examples with them. So this time I've got to get everything to one side, and I'm looking at my exponents, my variables, and this is to the 2/3, that's to the 1/3. Okay, I know if I square 1/3, I get, if I raise it to another exponent, I'm going to get to the 2/3 because I multiply those exponents together, don't I? So let's see if we can't say 5, get everything together over here first, 5x to the 2/3 minus 4x to the 1/3 minus 1 equals 0. Now, I have it in the right format. Let's decide what u is going to be. Let's try x to the power of 1/3. Okay. If x to the 1/3, then if I squared that, I would, have x to the 2/3. So I got 5u squared here minus 4u minus 1 is equal to 0. Okay, let's factor it. I have a negative, so I'm going to use a plus and a minus. I'm going to put my u's here. And I'll go over here just because and say 5 times negative 1 is negative 5, and this is a negative 4, the b term, and I've got 5u as my numerator when I'm fixing my factors, and I've got 1 plus and 1 minus. Now let's see, factors of negative 4 that will give, negative 5 that will give me a negative 4, and it looks like if I'm subtracting them, I am, one's positive, one's negative. What if I used 5 and 1, and I want it to be a negative 4, so I'm going to use the bigger one, negative. So negative 5 plus 1 would give me my negative 4. Now this one's fine as it is. It's 5u plus 1. And this one, I'm going to have to reduce them, right? So it'll be u minus 1. Checking it, 5u times u is 5u squared. 1 times negative 1 is negative 1. This would be positive 1u minus 5u is going to give me that negative 4u. So we have our two factors. And we can solve. So 5u is going to equal negative 1. Therefore, u is going to equal a negative 1/5. And over here, u is going to equal a positive 1. Let's plug them in and see what we find. When we say x to the 1/3 is equal to a negative 1/5, then we want to get rid of this fractional exponent, so we will raise it to the power of 3, right? 3 over 1, or 3, means we got to raise this to the power of 3 also. And when I do that, I have x. And then I have a negative times a negative times a negative, don't I? So I've got this negative times negative times negative, and raised to the power of 3 is going to be negative 1 times 1 times 1, right? And then I've got 5 times 5 times 5, which is going to be 125. So I have an x of a negative 1 over 125. Let's try this next one. We said x to the 1/3 is equal to 1 because u was equal to 1. We raise this to the power of 3, and then we also come over here and raise this to the power of 3, and we have x is equal to, well, really just 1. So I have two solutions, and they're not too complicated. Now, I put number 8 in here because I need you to think a little bit differently when you're thinking about u. In this case, I have my trinomial over here on the left, so it's okay. It's equal to 0, but look at my b term here. It is the square root of x. What is my a term? Well, it's just x. But if I take the square root of x and I square it, I do have x. So they really are, this really is the squared version of the square root of x. It's a little different way of thinking about it. What am I going to make u? Well, I'm going to make u the square root of x. So I can change it now. I can say this is 5 times u squared minus 7 times u plus 2, and that's equal to 0. I put this one in here on purpose because you needed to see a little bit different example of how this works. Once again, now we're good. We are just going to factor this. We're going to say u minus for both of them, right? And we can come over here and do our diamond. And we can say 5 times 2 is 10. Negative 7 is the middle, the b term. I've got 5u and 5u. And both of them are minus, aren't they? So what do I have? Factors of 10 this time. They're going to give me a negative 7. Well, factors of 10, that would give me negatives of 2 and 5. If I add them together, will give me a negative 7. Would give me 7. If they're both negative, 5u minus 2 is good. And this one, I can just reduce that. It's going to be u minus 1. Okay, check them. 5u times u, 5u squared. Negative 1 times negative 2, positive 2. Inside, negative 5u. Outside, negative 2u. There, I've got the negative 7u. So I go u minus 1 is equal to 0. And 5u minus 2 equals 0. And u is equal to a 1. And this time we have to work a little harder. U is going to, and 5u is going to be 2, and u is going to equal 2 over 5. So let's plug in the square root of x. This says the square root of x is equal to 1. Well, if I want to fix this, how to get rid of this radical, I basically just have to square it, don't I? So if I square this side, I get x. And if I square the other side, I get 1 squared, which is 1. Let's plug it in for here. We're going to say the square root of x is equal to 2/5, right? So I'm going to square both sides. I'm going to say this is really squaring it, I get x. And then I'm going to say, I guess I could write it out like this in case you're having trouble with it. If I square this one, I say 2 times 2, I multiply really 2/5 times 2/5, don't I? It's 2 times 2 is 4, and 5 times 5 is 25, so I get 4/25 is what I get. All right, next problem. Looks like this time we have to get a bunch of stuff on the other side of our equation here. So, and then I've got to do some work to get it in the right format that I need it. So that's kind of tedious, and let's just see what I have to do here. First, I'm going to leave this as a squared term and just see if it helps me out as a binomial that's squared, and see if it helps me out. I mean, it could end up making u equal to something like a binomial. But let's get everything to the other side. Let's add 12 times x plus 7 first, okay? So I've got x plus 7 squared. And if I add this term, it looks like it could be my second term. It would be plus 12 times x plus 7. This is beginning to look okay. And it's plus 32 and equals 0. Now check it out. I just moved this negative 12 times x plus 7 over. But if you think about this b term here, this b variable, it's x plus 7. And this is x plus 7 squared. So if I say u is equal to x plus 7, then I could call this one u squared. And that's what I want to do. So I kind of had to do some manipulating. I had to think about it a little differently, but it still works. Now, it's easy to factor this. Hopefully it's easy to factor it. It's going to be u plus for both of these. And we're going to look for factors of 32 that are going to add together to give us 12. And it is easy. It's, what is it? It's 8 and 4, isn't it? So I've got 8u, 4u, that gives me my 12u. Usually the first ones and the last ones are pretty easy for me to check. It's the inside and the outside that I really need to be careful about. Now I've got u plus 8 is equal to 0, and u plus 4 is equal to 0. And I've got u is equal to a negative 8, and u is equal to a negative 4. So what is that saying? Well, it's saying that x plus 7 equals negative 8, and x plus 7 equals negative 4. Now that's still not hard to solve. I'm going to subtract 7 from both sides, and x is equal to a negative 15. I'm going to subtract 7 from both sides over here, and x is equal to a negative 11. So there are my two solutions. Okay, just when you think this part's never going to end, I've only got 2 more for you to do, okay? And all I want you to do is see if you can work these on your own and then turn the tape back on and get back, watch the solution for them, okay? Basically for this second one down here, 11, just note that we have inside parentheses, we have something that's squared. Whatever it is, we can look at that and we have the same term inside parentheses here. So we can look at those as u and u squared, all right? And the first one is one that you should be familiar with. Now turn the tape off and start back when you're ready. So first I'm going to say u for this first one, number 10, is going to equal, again, the square root of x. That way I can say that 2 times u squared plus 9 times u minus 5 is equal to 0. And I can go ahead and factor that. I don't see a GCF to factor out. So I'm going to set this up as one of each sign. I'm going to say both of them have u, and because this is one of our complicated ones, I'll go ahead and demonstrate with the diamond method. 2 times negative 5 is negative 10, and this is a positive 9 here, and over here I've got 2u and 2u, just so that I know what to reduce if I need to. And I'm looking for factors of negative 1. Sorry, negative 10, that are going to give me 9. And I'm going to look at that and say, okay, what if I had a positive 10 and a negative 1? That would work. So this will reduce. This would be u plus 5. And this will not, so it's 2u minus 1. U times 2u is going to give me 2u squared. 5 times negative 1 is negative 5. Inside and outside are the ones I usually have to check. 10u minus 1u, that worked. U plus 5 is equal to 0. 2u minus 1 equals 0. U is equal to a negative 5. 2u is equal to a 1. And u is going to therefore be 1/2. So the square root of x is going to equal negative 5. And over here, the square root of x is going to equal 1/2. So I'm going to square this side. When I square the square root, I say that's x. And this is going to be negative 5 squared, right? Negative 5 times negative 5 is positive 25. So over here, I'm going to square this, and I'll have x. And I'm going to square 1/2. So it'll be 1 times 1 and 2 times 2, won't it? Or 1/4. Now let's go do this last problem we have as a demonstration. This time, like I told you in the hint, I'm seeing the exact same fractional. It doesn't matter how complicated it is. It's squared in the first term, and it's not squared in the second one. It can be u. So I'm going to make u equal x over x plus 2. It might be a little tricky when I get down to the end of this one, but it'll be a lot easier to solve if I do this, if I substitute in u. So I've got 2 u squared minus 3u. And look, I needed to get that 2 to the other side, so I'll just go ahead and do it. Subtract 2 equals 0, right? That helps me. It should have been the first step. So now let's see if I can factor it. It's not going to be hard to factor it. I'm going to say one of each sign. I've got u here and u here. And if you need to, you come over here and you say, okay, well, this is really 2 times -2 or -4. And I've got -3 in the bottom, 2u, 2u, and I had one of each sign, right? So what factors of 4? -4 are going to give me a -3, and it would be 4 and 1. But because the result has to be negative, the bigger one has to be negative. So in this one, I've got 2u plus 1. I can make that this factor. And over here, I'll reduce these. It's going to be u minus 2. Check them, and I think you'll find that they do work. But be sure you check when you check inside and outside. That's where if we have trouble, that's usually where we do have trouble. Now I've got 2u plus 1 equals 0. And u minus 2 equals 0. So 2u over here is going to equal a -1, and u would equal a -1/2. And u for this one is going to equal a +2. So now the hard part. Let's plug it back into this and say what I know is x over x plus 2 is equal to a -1/2. Okay. If x over x plus 2 is equal to -1/2, I have an equation with fractions. I need to multiply by the least common denominator. Well, the only denominator I've got is x plus 2 and 2. So my LCD here is equal to 2 times x plus 2. Okay? So I'm going to multiply both sides of this equation. We haven't forgotten how to do this, right? Times 2 times x plus 2 over 1. When I do the first term, the x plus 2's cancel, and I end up with 2x. When I do the second term, let's go ahead and say this one is going to be negative, okay? And when I do the second term, I'm going to say what cancels is the 2, and I'm going to end up with a negative x plus 2. Now, I'm not forgetting to put the x plus 2 inside parentheses because I will have to distribute that negative. So let's go ahead and do that. We'll say 2x is equal to -x minus 2. I need the x's together. Let's add x to both sides, and I'll end up with 3x equals -2. And when I divide by 3, I have x is equal to a -2/3. That wasn't too bad after all. Let's look at the next one. U, which is x over x plus 2, is this time equal to 2. Well, I only have one LCD, one denominator. It's going to be x plus 2 is going to be my LCD. I'm going to multiply both sides of this equation times x plus 2 over 1. I'll put these in parentheses so you can see it better. When I do this, my LCD times my first term over here, the x plus 2's cancel. I end up with x. And this is going to equal 2 times x plus 2. Because I had nothing to cross-reduce. So I have x is equal to 2x plus 2. Now, I'm going to take a weird little approach here. I've got x over here and 2x over here. If I move the 2x to the other side, I'm going to end up with a negative. I'm going to do the opposite. I'm going to say minus x from both sides. And that will give me just plain x over here. And then at the same time, I'm going to be subtracting 2 from both sides, right? Oops, it's supposed to be 4. Sorry. 2x times 4. So subtract 4 from both sides. And what I ended up with is, I'll rewrite it for you, as -4 is equal to x, or x is equal to -4. You might have taken a different approach to that one, which is fine. You got the same solution. We just have one more short little section to do called absolute value equations in this. So I've written some instructions for you, but if you have an equation with an absolute value sign in, basically you have a positive and a negative solution to it. So it's sort of simple. We're just going to set it equal to a positive and a negative, and that should do it. But first we have to isolate the term, the variable that has the absolute value. Because of the way this one's written, I have to add 2 to both sides. So the absolute value of x is equal to 6. Now, when I take away that absolute value sign, I have to say x could be a 6, but x could also be a -6, couldn't it? because absolute value has to account for distance, and it can be, between that number and 0, and it could be 6 or -6. All right, let's take a look at this one. Now, if I want to resolve this, I'm going to say this is, and it's already, the absolute value sign is already isolated over here. I've got the absolute value of x minus 2. So I'm going to say, let's try x minus 2 is equal to the positive 4 first, and that would mean that x was, of course, equal to a positive 6. And then let's set it up for the other side. X minus 2 is equal to a negative 4. So that would mean that x is equal to a negative 2. So our two solutions are 6 and negative 2 for this one. Let's do a couple more. This one, I really don't have the absolute value term isolated. I'm going to have to divide both sides by 2. So when I divide this by 2, I'll just write it for you, and divide this by 2, I have the absolute value of x is equal to 2. And then, of course, x would equal to 2, or x could equal negative 2. Now, what if we have the absolute value is equal to negative 4? Well, absolute value of x could be, of course, the negative 4. But if we also set it equal to the opposite, it would be a negative 4, right? Or a positive 4. Okay, so let's look at some other equations that we might solve with absolute value, a little bit more complicated maybe. This time I'm going to add 11 to both sides of this so that I can isolate the term with the absolute value, or the variable with the absolute value, and it's going to equal positive 11. And then I'm going to set those up. I'm going to say 2x minus 5 would equal 11. And I'll also say 2x minus 5, which is inside that absolute value sign, would equal the negative 11. And then I just have to solve. 2x is equal to, well, I'll add 5 to both sides, so I get 16. And then when I divide by 2, I get x is equal to 8. And this one, I'm going to add 5 to both sides. And that's going to give me a negative 6. When I divide by 2, I get a negative 3. So my two solutions are 8 and negative 3. Next, same sort of thing, but this time let's divide by 5. So when I divide the left by 5, I just get x plus 3, absolute value of x plus 3. And when I divide 35 by 5, I get 7. So now I'm ready to say x plus 3 is equal to 7, and x plus 3 is equal to a negative 7. And I can solve this one by subtracting 3 from both sides. And when I subtract 3 from negative 7 over here, I get a negative 10. So 4 and negative 10 are my solutions. Now, we have to make it a little bit more complicated than that, so let's put this rational expression in there, okay? We'll have a fraction. So it's already isolated for us, so we're going to say 2x minus 2 over 8 is equal to a positive 4, and then we're going to say 2x minus 2 over 8 is equal to our negative 4. Well, okay, LCD is 8. Let's multiply the entire equation, every term, by 8 over 1. This will cross-reduce, right? So I just have 2x minus 2 is equal to, well, I have to say 8 times 4 now. I get 32, don't I? Now it's easy. 2x, I'll add 2 to both sides, is equal to 34. And x is going to be 17 for this one. Once again, the LCD is 8. So I end up with 2x minus 2 because I cross-reduced, and then 8 times negative 4 is going to give me a negative 32. So I've got 2x. I have to add 2 to this side, so I'll get a negative 30. And this time, when I divide by 2, x is a negative 15.